the Earth observation field is still in the phase where contributing to just growing it is probably more important than growing your own position within it.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. That voice you heard right at the start of this episode, that was Gregor Milczynski, and he is the CEO and co-founder of something called Sentinel Hub. So in this episode, we're going to be talking a lot more about Sentinel Hub, but just to whet your appetite a little bit right here at the start, Sentinel Hub is a cloud API for satellite imagery. And in this episode, Gregor will be talking a little bit about the architecture, what you can do with this cloud API, and how it's different from other products out there. And more generally about the Earth observation industry itself, where it is now and perhaps where it's going to be in the future. During this episode, we reference Microsoft's Planetary Computer and the Google Earth engine. And it's worth noting that I have published episodes on both these topics before, and I will link to those in the show notes of this episode to make them a little bit easier for you to find. This podcast is sponsored in part by Lightbox. So you can find Lightbox at lightboxre.com. And what do they do? Well, Lightbox is a data platform, and it's an authoritative source of North American real estate and location intelligence data. So you're probably wondering, what kind of data are they an authoritative source of? So they have parcels, building footprints, administrative boundaries, census data, schools, demographics for neighborhoods, points of interest, school ratings, traffic volume for neighborhoods. As far as the property side of things goes, they have ownership information, loan and sales transactions, contacts and mailing addresses, historical aerial photography. So you can use the Lightbox platform to do your analysis in the platform itself, or there's a set of APIs that you can use to get a hold of the data that way and perhaps build your own analysis around it, or you can bulk download these data sets as files. If you're looking for a real estate information and technology platform, check out Lightbox. I'll put a link in the show notes to make it a little bit easier for you to find. Thanks, Lightbox. Really appreciate your support. Hi, Gregor. Welcome to the podcast. So you are the CEO and co-founder of something called Sentinel Hub, and that's really what I want to talk with you about today. But I think before we do that, would you mind just introducing yourself to the audience and perhaps describing how you got involved in Earth observation?
I'm Gregor. I'm working in this field for about 20 years already. And we still are operating a company that is working on geospatial data quite a bit. And about 5 years ago, we tried to make use of the Sentinel imagery, which was just announced then, and it looked really cool in one of our projects in Africa. And we realized that the technology that was available at the time to work with this data was simply not suitable for processing all these large volumes of always up-to-date data. And then you know how you have in every IT company a couple of people who believe that they can do much better than everyone else has done in the past. And so obviously we are IT company as well, and there were a few. And they said, let's do this much better. And this is how, basically Sentinel Hub appeared to be, because they actually made it work. We made the access to the satellite data, starting with Sentinel, but then also with other missions, much, much easier.
So obviously we're going to dive into all that stuff way more in the rest of the conversation, but it sounds like that. Was that a big decision, or was it just so obvious that this platform needs to be built? And when I think about Sentinel Hub, I think of it as a platform. Was that a scary, sort of risky decision for the company to make at that time, or was it just, of course we need to build this?
No, it was not a big decision. And by the way, it didn't start as a very large project. It started as a thing that 3 people were working on part-time for a few months. And then basically when it was working, obviously on a prototype level, we felt that that actually might be a good business. I mean, previously our business model was just custom-based application for large governments, right? So we didn't have a product at the time. And the Sentinel Hub was the first time that we said that actually might be a product. And then we started to invest more and more time. And fast forward for a few years. And now we have, more than 2/3 of the company working on things related to Sentinel Hub. And that's more or less all that we do as a company. So it kind of evolved naturally. It was not kind of, let's do something very big. We just started small and then evolved and iterated.
Thank you very much for describing that for us, because I think a lot of people will look at big projects and think they have to start big straight away. But it sounds like you said, start small, iterate on that, figure out what's working, keep building on top of that. And I think that makes it feel more sort of accessible for other people that are perhaps trying to build something themselves. So I appreciate that. That's sort of a rare look behind the scenes that we don't often get. So we've talked about a little bit now, Sentinel Hub. What is it today? If you have to describe Sentinel Hub to me now, you've been working on it for 5 years. How would you sell in the idea of Sentinel Hub to me, or describe what it is to me?
So I'll put my marketing hat on, hopefully the only time in this conversation, but as you asked. So basically we see Sentinel Hub as a AWS of Earth observation. I mean, AWS always said that they do the heavy lifting on top of the IT and so on. And we do the same with the EO data. I mean, we obviously make a lot of use of the cloud infrastructure and the data that are stored there and the data that are available on this cloud infrastructure to everyone. But simply the fact that we have, I don't know, 50 petabytes of data that is there, Sentinel, Landsat, MODIS, commercial missions, and so on. And all these complexities of multi-temporal and multispectral imagery, that's not something that is easy to tackle, even if you're using the open source tools that are obviously available, right? But I mean, if you really do things on an operational level, it takes a lot of time and effort because the data is always changing and so on. And basically, we do this for our users so that they don't need to do it themselves. And we expose the capabilities over a set of simple APIs. We really wanted to keep it simple and obviously also limited in terms of features, where the APIs where people can get ARD. ARD is another buzzword in this field. So analysis ready data. What is important though is that analysis ready data kind of depends on what kind of analysis you are working on, right? And the APIs that Sentinel Hub offers allow users to configure what is analysis ready for them. Various things like, I don't know, whether they want to do the auto rectification of Sentinel-1 imagery or they want to do some upscaling or reprojection, you name it. These are all just parameters in an API, and users are then able to, with one simple API request, get immediate access to full and global archives of just about all the relevant satellite missions.
Wow. Wow. So if I try and summarize this just a little bit, and I apologize for the oversimplification, which is about to follow, you have access to a lot of satellite data that's living on the cloud, and you expose that data through APIs. So people can call these APIs and process the data and have it returned to them in a format they're expecting. Am I on the right track?
Yeah, I mean, we could hire you for a marketing. I mean, yeah, that's exactly what it does, indeed.
Okay, so when I think about this, I think my first question is this processing. Are you pre-processing all this data? Are you doing auto rectification on every image that comes down from Sentinel and Landsat and the other satellite data that you talked about? Are you georeferencing them? Are you correcting for atmospheric distortion on every single one and then like saving them out as different formats? Is that what's happening behind the scenes to make it easy for me to access this data through the API?
That's a very good question, and this is actually the first thing that we asked ourselves that 5 years ago when we started on it. But then the answer was very quickly no, right? Because just the sheer size of the data that is out there and the data that is typically hosted and the hosting paid by someone else, I don't know, like European Union pays for diocese, Amazon offers it, and Google Cloud offers it in their environments. And you can access this data without any cost. Now, as soon as we start to reprocess this data, we suddenly have to store the data ourselves. And I mean, you can very easily calculate how much it costs to store 50 petabytes of data. And I mean, we are a small company, right? We are 75 people, bootstrapped. We don't have any venture capital. I mean, we never were able to afford ourselves to pay, I don't know, millions for storage or for processing. So rather than that, we invested a lot of time into optimizing the processing steps as much as possible so that we can do all of these things basically on the fly. And it takes, depending again on what you do and the volume, but it takes from a couple of hundreds of milliseconds to maybe a couple of seconds for the most usual requests. So everything, and you mentioned auto rectification. So if you go and ask for Sentinel-1 data, what we will do is we will fetch the data from the bucket, the relevant data. We will fetch the digital elevation model from another bucket. We'll do the auto rectification. We'll do the radiometric terrain correction, speckle filtering, and backscatter coefficient. And this would take about half a second, which is typically fast enough that our users can actually integrate this directly in their applications in an interactive manner, right? Without, again, them storing the data on their side.
Would a request like that, could it also include transforming the data into another file format?
Yeah, it does. Yeah. And reprojecting it and upscaling, on downscaling, using different rescaling techniques, or doing the composites, doing the, let's say, multi-temporal mosaic, doing some indices, even to some extent, some machine learning models, applying some machine learning models on top of it. Again, there are limitations, to be clear. It's not that you can do everything, but you can do a ton of stuff with it. And I'd say that it covers, I don't know, 80% of everything that people would want to do. They can do it with one API request with a simple function.
So I totally understand the business case behind this. You're saying it would cost a lot of money to take all that data and store it and maybe double, triple, quadruple the size of it by pre-processing it and turning it into different file formats, and then just hoping someone showed up and wanted that file format, for example. That makes a lot of sense to not to do that and just to process it on the fly. But I'm wondering if there's also, if some of your thought process was around every time you process the data, don't you add a certain error to it? I mean, I'm thinking if you took all the raw Sentinel Landsat data and turned it into five or six different file formats, cogs, for example, are you not also adding a certain error to that in every processing step?
In short, yes. I mean, it depends what you do, right? You can be careful and keep the same projection and so on and so on. I mean, some data, as an example, Sentinel-3 and Sentinel-5P, they are in the satellite projection, right? So if you want to project them into the WGS or something, you are actually introducing an error. And therefore, when you would do another reprojection, the data would be of worse quality. But then it's even more than that, right? Because I mean, if you process the data, like pre-process the data, then you have a fixed set, right? And let's say that you improve your processing capabilities. Now, if you want to improve your data set, you need to reprocess everything once again, which is obviously very expensive by itself. Whereas what we do is we just deploy a new version, and you have all these new capabilities and new improvements available directly without any change whatsoever.
Do you ever cache any of these calls, the results of this processing, just in case the user comes back?
We did have cache at the beginning because we wanted to make it again as fast as possible. But what we realized is that when you are working with the, let's say, satellite mission like Sentinel-2, which has new data every few days and it's global, right? So it happens very, very rarely that people want to get exactly the same data at exactly the same location, exactly the same time, the same band combination or the same bands. So what we realized is that if we cache things, then yeah, we are introducing a new layer, which is causing some overhead, but it's very rarely used. So we just dropped cache and put some more effort into making the processes just a tiny bit faster so that we could work without it. Basically, we have no cache whatsoever. You everything that we do is on the fly, and we then delete everything, and we are fresh.
So now for some of the big questions. Like, I imagine people look at this and go, "Well, how is this different from the Google Earth Engine, for example? How is this different from the Microsoft Planetary Computer?" How do you answer that question?
Yeah, it's a question that we do get often, and it actually depends because Google Earth Engine and Microsoft Planetary Computer are not the same. So let's start with the Google Earth Engine. Where we see the main difference is that Google Earth Engine was a platform designed for research where people could just go there and do an analysis and then make use of the results. I feel that Google Earth Engine was not designed to power other applications. I mean, yeah, you have ways to work around it and expose the data, but generally it was to make an analysis and then work with the results. Whereas the Sentinel Hub was always made to power other applications, right? We don't want to be the one-stop shop because we don't have all the capacity. We offer set of APIs and then people integrate this in their procedures. This obviously makes it a bit more complicated. I mean, it's easier to go to some web browser and just run stuff and get results, but it also removes quite a bit of limitation. I mean, if you in Google Earth Engine you cannot do something, then you simply cannot do something. It's bad luck for you, right? Whereas with Sentinel Hub and your workflow on top of it, you can do just about everything because you have this option to, I don't know, fine tune what you would like to get from Sentinel Hub and then work from there on by yourself. I mean, then there is obviously one very important difference is that Sentinel Hub is a payable service versus Google Earth Engine is free, at least for non-commercial use. But again, if you start using it commercially, where at the moment at least Google Earth Engine is a bit tricky because it doesn't have clear pricing policy, then Sentinel Hub is much cleaner. Now, in terms of the planetary computer, I feel at the moment that Microsoft kind of said, look, we'll just make the data available in a cloud native way. We'll provide some APIs to access the metadata of this data. And that's basically it, right? Everything on top of it is your own process running in your own virtual machine, which obviously can run on Azure. But it doesn't abstract none of the complexity of the satellite data. Even if you just want to do, I don't know, stitching of the scenes, that is tricky. So I feel that the Microsoft Planetary Computer is kind of similar to Amazon Open Data Bucket, where you just have the data with maybe a few more APIs on top of it, but it's not significantly different. And yeah, I mean, you can do way more things with the Sentinel Hub than you can do with the Microsoft Planetary Computer.
Okay, so when you explain it like that, I feel like at one end of the spectrum we have the Planetary Computer from Microsoft. At the other end, we have Google Earth Engine, and it feels like Sentinel Hub is in the middle. I guess, at least for me, when you describe it in that way.
I would agree. I mean, it is so. And again, the Sentinel Hub was designed to be used by people from their own environments. So, I mean, if you are working on Microsoft Planetary Computer, you are in Azure. If you want to run Planetary Computer from, I don't know, Google Cloud, bad luck. Whereas Sentinel Hub APIs, I mean, they are APIs, you can run them from everywhere. And people appreciate that because they have their own infrastructure, they have their own proprietary data which they don't want to share with others, right? And basically they just use Sentinel Hub as a data stream in their procedures from wherever they are.
Yeah, so that makes perfect sense to me. And thank you very much for walking us through that. So who is using this? You talked about people building applications on top of Sentinel Hub. So Sentinel Hub is the back end feeding the data in, doing the heavy lifting in terms of the cleaning, processing, providing this, quote unquote, analysis ready data that we are talking about earlier. Who is building applications on top of it? And what kinds of applications do you see people using or creating?
I mean, we have a couple of types of users. A vast majority of our users are really either application developers or data scientists. We have a few that are actual end users who just integrate their APIs in, I don't know, QGIS or ArcGIS and they use it there. But these are very few. Now, in terms of the application developers, this would be mostly working in the field of agriculture. The reason is very simple, right? That Sentinel-2 is a really powerful data collection, and it's because of the resolution most useful for agriculture and vegetation monitoring and so on. So you have most of the use cases there. We also offer the other missions, including the VHR commercial emissions, but then it gets much more expensive because of the licenses. So typically, many of the precision ag applications are powered by Sentinel Hub. You wouldn't know that because it's in the backend, or maybe if you go and look in their code, you would actually see them making a request to the Sentinel Hub. But they basically, there are applications where farmers then come and do the, I know, variable map and so on. So that would be one sector that is probably the largest in terms of the application developers. Then in terms of the data science, it also is quite a bit leaned toward agriculture. Again, it's importance of the field and the climate change and so on. But what they do is they typically do the monitoring on large scale. Either they try to detect crop type, or they try to detect land cover or the agriculture activities happening. And the funny thing is that I'd say that we have about 95% of our payable users. By the way, we have about 1,500 payable users, right? 95% of the payable users are application developers, but the 5% of those that are actually data scientists, they consume 80% of the volume of the data, right? Because as soon as you do the machine learning, you consume orders of magnitude more than if you would just provide the data to the users. So it's not just agriculture. We have people from mapping. I mean, I can mention TomTom as an example because obviously they mentioned us. I can mention in agriculture Class and 365 because they also revealed this. We have to keep these things confidential mostly. Maxar is using our data. They are integrating it in their secure watch. It's quite a bit of the oil and gas sector is using the data, the raw minerals, then obviously environment monitoring. Defense is probably the least of the sectors that we serve. Mostly it's really the agriculture, the energy sector, and so on.
So you've got these massive global data sets that you're working with. You're working with a lot of different industries. If you had to look at where the geographic areas that are using most of the data, or the areas that people are most interested in terms of geography, where would those areas be? Is it Are people looking in Europe? Is it North America, Africa? Are there specific countries or perhaps areas within specific countries where you see a large amount of data consumption happening?
Generally, in terms of our user base, it's quite a bit global. I mean, probably the Asia is the least represented, and I imagine that this has also to do with the Chinese firewalls and so on, because it's just difficult to use APIs from outside. But generally, yeah, we have users from Africa, Australia, South America, Americas, and Europe. Now, in terms of the areas that are most consumed, we don't actually track this per se because of the privacy and so on. My gut feeling, though, is that the Europe is currently quite a bit heavy in terms of the consumption, because I don't know whether you're aware of this area monitoring activity in the from for the monitoring of agriculture subsidies, which is like a very important driver of machine learning based services on top of satellite data. And this is all done over Europe, right? So you have lots of countries that now process just about all the data that they are in their countries, and this just makes it, yeah, a large consumer. But I mean, TomTom, as an example, they process the whole world of data when they were creating their medium resolution layer. So yeah, they consumed everything that there is.
Could we go back to that European example for a second here? Can you sort of dive into that policy a little bit more? What are these data scientists doing with the data that European policy is made mandatory? I just want to understand that a little bit better.
So in Europe, you have this common agriculture policy, which basically is distributing significant sums of money, like about half of the European budget goes to farmers to better manage their lands, right? Now, this better manage their lands started with, from, I don't know, a couple of decades ago, just do cultivate them. But now it's going more and more into how to do this in a sustainable manner. Like, I don't know, what are the good agricultural practices to make sure that the land is not overused, or that there is not erosion and so on happening, that the biodiversity is still there. And previously, I mean, again, for the last maybe a decade or so, this was all controlled using the so-called on-the-spot checks. They went to the field and they checked how things are working. But now with this systematic acquisition of satellite data over like whole Europe and obviously whole world, you now have an ability to monitor some of these practices, not everything, but some. You can monitor just using satellite data. And I mean, these practices are, for example, was the field mowed, or does the field have this kind of crop type, or was there a grassland that was converted into the arable land, which you shouldn't do if you have a permanent grassland. So many of these kind of rules that are in place, which actually can very easily be monitored using both the Sentinel data, Landsat data. Sometimes you need to go into, I know, PlanetScope is often the only alternative, simply because of the systematic monitoring. But yeah, majority of it is based on the open data. And what they do is that they process the data over, I don't know, tens of millions of the agriculture parcels in Europe, and they check for these activities whether they happened. And then if they happened, or I mean, then the farmers might have to return the subsidies or something like that.
So you talked before about agriculture being this huge sort of use case, and data scientists being the biggest consumers of your data. And seeing this happen, like seeing people making those requests and trying to answer those questions that you're talking about, are people following the rules essentially, monitoring the agricultural lands in Europe? Is there any temptation on the Sentinel Hub side of things to say, oh, well, this is a standard question. We could create a standard answer. So instead of people doing the processing themselves, we can move that and provide that as a data product on our side?
We do ask this question ourselves quite a lot. Now, in most cases, the answer is no. And I mean, the simple reason is that we have a limited capacity and we need to focus to things that we really, really know best. And this is data processing. And we don't know a lot about, I don't know, forest monitoring. That being said, the agriculture field is actually one of our strong suits, because we are working in this for the last 20 years. This is how we actually started. So we have significant experience in common agriculture policy, all this data. And then now we learned the machine learning. And we actually are developing a suite of services on top of Sentinel Hub, which we called Area Monitoring Suite. And these services provide information such as, yeah, what is the parcel boundary of this field, or was this field mowed, when was it mowed, how many times was it mowed, what kind of a crop type there is. We do have this already, and if you go to our blog You will see lots of posts about that. But yeah, generally, we very rarely go into these other things simply because there is so much and these things are so complicated and there are so many smart people out there who can do things better than us, and we rather support them doing it than us trying to do just about everything out there.
Yeah, and I completely understand the need to focus. Like, what are we good at? Where is our unfair advantage, and how can we increase that over time? And it sounds like that's what you're doing. So we've been talking about satellite data, and you've named a bunch of different satellite data sets that you're working with. Sentinel and Landsat come up again and again during the conversation. If I had my own satellite constellation, I was collecting large amounts of data. Can I just plug it into your system and make it available through Sentinel Hub? Like, what would I need to do, or what would have to happen on your side for this to work? For me, just to say, here's a bucket full of my data that I'm updating on a regular basis. Please make it available.
So technically, actually, things are already there. We have this service called Bring Your Own Data, whereas only thing that you need to do is get your data in one of the cloud native formats. At the moment, we support the cloud optimized GeoTIFF and ZAR. And yeah, you need to put it on a bucket close to one of our deployments. And then there are APIs which you trigger to say to Sentinel Hub, look, this is where my data is. We will collect the metadata of this and we will store this metadata in our database simply to be able to process it fast. We obviously wouldn't copy the data, right? As we don't do it with Sentinels and others. And yeah, then I mean, you can then make use of this data via the same set of services with the same set of features that we have. What we at the moment don't yet have is that we could support the like automatically the charging of other users to use this data. So, I mean, if you are a satellite provider, you would need to take care of this charging by yourself. But yeah, technically, all the things are there and are readily available. And I mean, just to say that I think it's a very important question because now you have lots of companies launching hundreds of satellites. But I spoke with quite a few of them, and nobody's actually thinking on how to distribute this data efficiently, right? And at some point, if you want to make revenue with the data, you obviously need to do that. And yeah, I mean, our approach is why would you try to rebuild this by yourself? You can just make use of Sentinel Hub. We also do offer like white label solutions so that we have customers who want the service to be run on their premises, on their cloud, just for their set of users. We do this as well. I mean, an exception that we do, but we do that, right? So it depends on the needs. But yeah, the whole data distribution thing can be done with Sentinel Hub.
Would this also be true for any sort of large set of imagery? I mean, does it have to come from satellite? Could it be imagery in general?
A very good question. Yeah, you're right. It can be any raster data. I mean, we even now we host not just the satellite data, but also some derived products. Like I don't know, ESA World Cover. It's a super useful collection to do the machine learning on top of it. Or Copernicus services, which have all these phenology indices and so on. So basically, any kind of raster data that you have can be served via Sentinel Hub.
So you talked about machine learning before, and earlier on in the conversation as well, and we talked about analysis ready. Like, how much machine learning can I do today? Like, again, there must be standard questions that people are wanting answers to that you can see. Like, they always show up and ask this one question. Do you consider creating these machine learning algorithms, object detection algorithms, and offering that as a service? So I don't get imagery, I get an answer.
I mean, surprisingly enough, I think that the machine learning field is quite a bit in an immature state at the moment, right? You have lots of questions, but most of these questions don't have a operational procedure to provide answers to. I mean, you have examples, you have prototypes, you have papers which show nice images. But if you say, look, I would like to get to run this process for over that area, most of these procedures will actually not work. So, I mean, what we did is that, and by the way, one of the reasons for that is that it's really complicated because the situation is changing quite a bit when you go from the field to field or even use case to use case. As an example, change detection, right? Everyone wants to do the change detection. But what is change? What is change? I mean, is just, I don't know, maturing of a cornfield. This is obviously change, but is this a relevant change? And so on and so on. So, I mean, what we did is that we started by open sourcing our machine learning procedures that we have developed internally to address some specific customers. and we host them on GitHub as a MIT license, so that other people could make it easier start to take these procedures and then to refine them for what they need. And I'm pretty certain that they will need to refine them for in most cases. I mean, there are some that actually work quite well. Like we have a parcel delineation library out there, which seems to work quite well just about in any part of the world, at least where we tried it. And but in most cases, you will need to adjust your procedure to your specific workflow, and then also to you, often to your specific area. And to generalize this to kind of offer just as a service, yeah, you can do this for a very limited set of things, like, I don't know, airplane or ship detection, maybe buildings, maybe roads. But in practice, all the things that really are valuable, they typically require quite a bit of thinking on top of it, of these basic tools.
And sometimes I feel like machine learning is thrown around as this sort of blanket statement. I will do this with machine learning. And yeah, that might be the tool, but I think it sort of glosses over how difficult some of these things really are to do in practice, just exactly like what you're saying there.
I mean, I could not agree more. And I mean, you can actually really do many of the things by, I don't know, just taking the data and labels and throwing it into TensorFlow, and you will get results that actually look good. But then, if you really try to make use of these results, when the details matter, then you will see, I don't understand why this is so. I don't understand why this is so. And then, when you will try to fix this, you will suddenly realize that, yeah, what you have done is maybe, I don't know, 20% of the work that really needs to be done. And yeah, the most difficult part are still waiting for you. And so machine learning definitely is a powerful tool. And by the way, we use machine learning a lot. We typically use the most simple things that are possible. Like we go into the deep learning very rarely, because often the random forest does it as well. But yeah, the things that you need to do aside of this just core training or running the model are typically way more difficult than, yeah, just one simple process.
So when I look at the Earth observation industry, and I call it an industry, I'm sure there's some debate about that. But when I think about Earth observation industry, and I think about the Earth observation data, and this combination of large volumes of imagery and the excitement that is around machine learning, object detection, deep learning at the moment, AI in general, I think wow, this is like the perfect storm. And I think people like me look at these two things and go, wow, there is so much opportunity here. And I guess this is why we see a ton of investment going into new and existing satellite platforms. But when I was talking to you earlier, we were talking about these opportunities, and I asked you like, what is the main reason why a lot of these opportunities aren't being realized, or we're not seeing like hugely successful, or at least a lot more sustainable business in the Earth observation sector? Your answer was something like fuzzy pixels. Can you explain to me what you meant by that?
First of all, people often have very wrong understanding of what satellite data really are. I mean, people expect to get Google Maps like imagery, and they expect to get it like, I don't know, on an ongoing basis. We actually do get questions from people. Can you get me have a meter resolution data from 2 months ago at 9 a.m. to 9:30 a.m. something like that? I mean, people have very unrealistic expectations, and then they dive into the what is really available. And I mean, when you go to the systematically available, this is really just Sentinel, Landsat, and PlanetScope. I mean, everything else that is higher resolution is tasked and is very. I mean, you have to be lucky that you will find something in the area and time that you want. And now, resolution of Sentinel and so on. I mean, it's typically not what people expect, right? I mean, to identify a building in Sentinel-2 image, I mean, it's a difficult, even though the resolution is 10 meters and buildings are often larger than 10 meters, but just identifying one single pixel typically is not really easy to do, right? So there is, yeah, I think that people are still not experienced enough into how to make use of this multi-temporal and multispectral value of the ongoing satellite missions. And that's something that, yeah, it's just new for everyone. I would agree that it's changing fast. I think that I kind of feel that Sentinel-2 really made a revolution here, because it provided a very useful and good quality and free data set that now people suddenly can actually start building tools on top of it. But then when this happened, you now need people who actually understand what they're doing. And previously you had, I don't know, maybe thousands of remote sensing experts. in the world. I think that now this is slowly changing with more and more people being comfortable with the data. And I hope that I know our EO browser, which just allows everyone to make use of it and get familiar with it, helps in this respect. So now there are more and more people that have an idea what they would like to do. Then they typically try to do it and they see that it's difficult or sometimes impossible. But yeah, the more of these ideas that there will happen, the more you will get some of these that actually materialize and end up in something that's working. I mean, again, to find things that use satellite data and are really, really working, there are few. I mean, going beyond the showing NDVI and precision application, most of the other things are prototypes, right? Exaggerating maybe a bit, but just a bit.
So let's imagine for a second I could snap my fingers and I could increase the resolution of something like Sentinel-2 by an order of magnitude. Do you think I would automatically increase the value that could be derived from from an image by an order of magnitude? And I guess what I'm getting at here is that there must be the law of diminishing returns must kick in at some point.
I mean, I think that the short answer is yes, because most of the challenges that people are trying to address with satellite imagery, they do require to see an object. And 10-meter resolution is typically not enough unless your object is a field or a forest, right? Or I don't know, a water basin. So if you go to I don't know 1 meter or half a meter resolution, I think that it would change drastically because I mean, people would have these ideas and it wouldn't bump into a wall. You would then end up with, oh, it's quite a complicated and costly to process all this data because suddenly you have, I don't know, orders of magnitude more volume to process. But still, yeah, it would for sure help quite a bit if you had lots of high resolution data. But again, very importantly, we are talking about systematic monitoring. I think that for all the challenges that people are interested in, I mean, they all require the data to be available on a regular basis. I mean, we have tasking in VHR resolution for decades already, and this works fine for a very limited set of problems. But if you want to really do some monitoring, then you need to have data available, I don't know, at least every week, or maybe, yeah, every week is probably the minimum. I don't think you need it every 15 minutes that you have startups trying to create the constellations for that. A day is very nice. A week is probably sufficient. And yeah, resolution of half a meter to meter, I think would really do magic.
I think in terms of the temporal resolution, I think it would depend a lot on what that meaningful change was that you were looking for. You know, if that how long was that happening? Or, you know, what time period are we interested in? When does meaningful change happen? I think once you define that, then you could come back and say, well, meaningful change for us happens every day. If it's a construction site, maybe, or if it's agriculture, I can definitely see the week as a great time period that you were talking about before.
I agree about that. And there are some changes that actually do happen that they need to be monitored more frequently, like wildfires, right? I mean, for wildfires, you have these EUMETSAT satellites, which already now take the data every few minutes, and that's typically sufficient. But if you go to the higher resolution, I have a hard time understanding what you would need the data more than daily on a large scale, right? I mean, it becomes even probably too costly to actually check all this data compared to how often the changes really happen, right? Because in most cases there is no change, and if you have to process, I don't know, tens of petabytes of data every day just to find 100 cases where you have relevant change, I don't think the value that you will generate is high enough to actually compensate for the cost that your process will have.
Yeah, I think that's a really good point. Thank you very much for that. Appreciate it. Hey, you mentioned something called the EO browser before. Do you mind telling me what that is?
So EO browser is a Google Maps like application that runs in a browser and provides access to just about all the missions that we support. So Sentinel Landsat, MODIS, Copernicus services data. You can even get commercial data through it. And what is important is that this is free to use for non-commercial use. Again, the exception being if you want to go into the commercial data, then there are obviously licenses to pay. But yeah, you go there and you go to your favorite place in the world and you check for the most recent data, and then you can interactively visualize it. And again, I mean, here I'm talking about interactively, meaning that you see an image immediately. You can zoom in, you can zoom out, you can do different kind of band combinations. You can go back in time for a couple of months, or maybe you switch to Landsat and you go to a couple of decades. You can do time lapses. You can do, I mean, you can do many of the analysis that people would, I know, often do in the Google Earth engine. You can do it in the EO browser with, I mean, just with the browser. Not even, you don't even need to have an account, right? You just go there and you just play with it, and you can see changes happening in front of you. You can do various kind of indices, the detection of water bodies. All of these things are just available within a browser in a couple of seconds.
So this sounds like an incredibly useful tool, right? But my guess is it's also been a really useful marketing and education strategy for you. Is that the case?
Yeah, actually, it is. I mean, we created it quite early because we wanted people to see what they can do with the Sentinel Hub. Because EO browser by itself is basically just a front end that triggers the APIs behind, right? And we wanted to have it as a showcase application. That was the one objective. The other objective was that we wanted to simply raise the awareness of the remote sensing data, of these complexities that I mentioned previously. We wanted to make it easier for people to address so that they could come up with the ideas. And yeah, I mean, one very important point is that it also shows that our services work, right? Because in Earth observation field, you have lots of things that just somehow work, or that just I don't know, are marketed to work. But EO browser is a tool that I think it has now like 140,000 monthly visitors. So it's like heavily used. We process, I think, 50 million requests a month with it. And yeah, I mean, you're right. It's a market. It's probably the only marketing channel we have. The only other one is Twitter. We have a Twitter account. We don't do almost any other kind of marketing than that. And people just know us by EO browser. Unfortunately, though, many people see EO browser and then they believe that Sentinel Hub is that, right? That it's just visualization. Whereas we want to communicate that Sentinel Hub is actually the backend behind it, which they can use to build their own workflows and so on. So that's something that we are still, I don't know, lacking on how to communicate properly. But yeah, people know us pretty well based on your browser.
Well, how long ago did you build that? Because what did you say? Like 100,000 visitors a month and 50 million requests a month. That's huge. How long did it take for it to get that kind of traction?
I believe that that we built it 4 years ago, 3 years ago, 3.5 years, something like that. And yeah, it took a while because remote sensing is such a small niche field. I mean, 100,000 visitors might sound like a small number if you compare it to just about any, I don't know, social media stuff. If you think about that here, this is really interested for people who know a bit about satellite data, or they want to explore satellite data and not just, I don't know, look at faces and kitty pictures and so on. I believe that 100,000 is quite an achievement in this field.
Yeah, absolutely. I think it's remarkable, and I think it's a brilliant strategy as well. Education, marketing, showing what you can do instead of talking about it. I think it's brilliant. I hope that it's really working for you.
I think it's working really nicely. And what we are really happy is that we really see how people make use of it, like to educate themselves. So we just recently have seen some document that was done by, I think, the Academy of Sciences of the Ukraine. They built a 150 pages document on how to make use of satellite data. And EO browser like is the first thing, and 50 pages are just about how to do various things in EO browser. I mean, and it's often used in schools, and people just, yeah, they get familiar with the satellite data by using your browser, and that by itself makes us happy, right? Even though it's not generating direct revenues, but if we contribute a bit to making people know what they can do with satellite data, then we did a lot already.
Yeah, and I think like from an industry standpoint, like that kind of education, showing people what's possible, what the data looks like, making it easy to interact with. You would hope that like that sort of rising tide of understanding would lift all ships. At least I would.
That's our hope and assumption as well. And this is also why we share quite a lot of what we do openly, right? I mean, as mentioned previously, we share the machine learning procedures and so on. And some people ask us kind of, why don't you keep this for yourself? Because, it's like proprietary know-how and you can valorize that and so on. But what we say is, look, I mean, we believe that if we help to grow the market, this will actually help us as a company much more than if we, I don't know, keep things for ourselves and we try to address this, I don't know, few hundreds of customers that are available right now. Plus, obviously, that when we raise the market, then we actually contribute a bit to the world as well, which is becoming more and more important. But yeah, I think that the Earth observation field is still in the phase where contributing to just growing it is probably more important than growing your own position within it.
I totally agree. I think growing the pie instead of fighting over the slices of the pie. I mean, I think that's always the best option. So we were talking about growth and we're talking about marketing here. So perhaps it's a good stage to sort of round off the conversation with a question about where do you see growth coming from? So I think I remember you saying you started building Sentinel Hub about 5 years ago. So if we look out from now and look at the next 5 years, where do you see your growth coming from?
One part of the growth will simply be the users that we currently have. They getting more and more of the end users themselves, and therefore they will be consuming more and more of the data. But where I think where there will be a really changer is introducing this monitoring approach in just about all elements of our life, right? Where people will be proactively processing again in a smart way so that it is cost efficient vast sums of the data in order to identify places where we have to take a deeper look in. I don't know, places where the deforestation is happening or the reforestation is happening, or the places where people are saying, here we are doing all these carbon sequestration efforts and so on. But so far, nobody was actually checking all of these statements, right? And all of these methods will obviously need satellite data because it's such a rich and useful resource because it's objective, it is systematic, and so on. And then, they will all need to get this data into the form that will make it easier for them to actually extract information. And we believe that Sentinel Hub is and will be the best place to do so. And this is probably 1,000 times more than what we see so far. And I think this is not something that will take 5 years. I would guess that in 2 years' time, we'll have a completely different world in terms of how much machine learning is used, like in a daily basis. People not even knowing that they are seeing results of machine learning on top of satellite data, and but all of these processes will have to run somewhere, and there will be a ton of the data consumption.
I could see your vision having a massive sort of flow-on effect as well, because if people are using more of your data, then there's going to be more need for data scientists, more people downstream working in the industry, creating these algorithms that we're talking about before, doing the machine learning, doing the analysis. So you foresee, if I had to summarize this, that the pie will grow dramatically within the next 5 years.
The example I like to give is that I would like that when I'm as an individual, I'm in some fast fashion shop and I'm looking at buying some t-shirt, and I would like to understand what kind of impact my purchase of that specific t-shirt will have on on some rivers in Indonesia where they are making the fabric for that specific t-shirt. I mean, all of this is possible to be done with satellite data in a very easy manner. There is a ton of things that need to be implemented before, and we are just doing a small tiny piece of that, right? But once we kind of crack as a community all these small parts, then I mean, this will be used on a daily basis at such a scale that we can't even imagine it right now. So it will for sure. I mean, it has grown. We grow about 100% per year by itself, right? Just now, but and this will just grow faster and faster.
Gregor, I've really appreciated your insights. I've appreciated the conversation. And I really love the way you break things down. You answer questions in such a concise way that even a non-expert like me, I feel like I know more about the industry and about what you do within the industry from this conversation. So I really appreciate it. We've mentioned the name a bunch of times here, but Sentinel Hub, is there anywhere else people can go if they want to learn more about it, if they want to find out more information, or if they want to try out things? Is there anywhere we can send them?
So I would recommend going first to EO browser because it really nicely show what the data can do. Then the next piece is probably our Medium blog post, Medium/Sentinel Hub, where we share a ton of knowledge of what you can really do with this data. And then Twitter channel Sentinel Hub is also communicating lots of new stuff that we do. That's probably it, and obviously a website, sentinelhub.com, right?
Wonderful. Thanks again for your time. Really appreciate it. I'll put links to all of those places in the show notes to make it easier for folks to find.
Thank you, Daniel, and thank you for making people know about these things because they are really powerful.
Thanks again to Lightbox for sponsoring this podcast episode. If you are in the US or Canada and want to locate your customers and prospects using addresses, geocoding, and property information, or if you're working in real estate, government, telecommunications, insurance, energy, or utilities, check out Lightbox. That's lightboxre.com, and there'll be a link in the show notes of this episode to make it easier for you to find. Thanks, Lightbox. Really appreciate your support. So I really hope you enjoyed that episode with Gregor, the CEO and co-founder of Sentinel Hub. There'll be a link in the show notes of this episode to Sentinel Hub and to the EO browser, which is a fantastic tool and well worth trying out. And I mentioned right at the start of this episode that we've covered some topics that we talked about in this podcast episode. So in previous episodes, we've talked about Microsoft's Planetary Computer and the Google Earth Engine. And both those episodes will be linked in the show notes of this one. And that's it for another episode of the Mapscaping podcast. Thank you very much for tuning in again this week. Really appreciate it. I'll be back again next week. I hope that you'll take the time to join me then.